Okay, so review of right triangle trig. Okay, so this is right out of 10C that you've done already. Now, what we want to do is want to just talk about the sides right now. And the sides that we're talking about are the opposite, the adjacent, and the hypotenuse. So you remember that from grade 10, that's your SOHCAHTOA. Right? Sine equals opposite over hypotenuse. Cos equals adjacent over hypotenuse, and tan equals opposite over adjacent. The trick to these is finding what opposite, adjacent, and hypotenuse are. And we always do that from the angle. So how I always do it is if I was standing here and I was looking this way, there's only, if I had a bow and arrow in my hand, there's only one wall I could hit, or one side. I mean, it would skim along this one, and it would skim along this one. The only one that it would hit is this one. This is the one I call my opposite. Now, the adjacent, it is always the angle that attaches the 90 degree to the angle you're looking for or that you've been given. So this is always the adjacent. And the hypotenuse is the side that does not touch the right angle, and it'll be your longest side of a triangle. So we look at B. Well, this is our angle. So if Y was a person, they could shoot a bow and arrow to there. Well, they could shoot the arrow with their bow over there. That becomes my opposite. My adjacent joins my angle and my right angle. And then there's the hypotenuse, which is the longest side of the triangle that does not touch the 90. Okay, so then when we look at, for this first chart here, so it's kind of like split here. So sine here is opposite over hypotenuse, right? Opposite is DE, and hypotenuse is EF, or FE, whatever, right? Opposite over hypotenuse. This is the opposite, this is the hypotenuse. Cos is adjacent over hypotenuse, so that would be DF over, because that's adjacent, right? We're just, here's DF, and here's the adjacent. We're just plug and play right here. And hypotenuse is FE again. Tan is, I should put hypotenuse here. Tan is opposite over adjacent, right? So my opposite is DE, and my adjacent is DF. Okay, and I don't think we need to do the second triangle. We should be able to see how that works. Okay, so lots of review here. So remember, these are all going to be huge. And again, it's always from your angle, right? From here I can shoot, that's my opposite. Here, this would be my opposite. So triangles, you always have to do it from the angle that's being talked about. It's either asking for this or giving this. Okay? So these, obviously, opposite over adjacent for tan, and opposite over hypotenuse, right, for sine. And then Pythagoras, we're going to be using Pythagoras a lot. So a squared plus b squared equals c squared. And the way this always works, right? A and B, altitude, base, and C is your hypotenuse. Okay, use Pythagorean theorem to calculate the length of ST. Okay, so let's label this. This is my base, this is my altitude, and this is my hypotenuse. Okay, so we are looking for, well, we know our formula is a squared plus b squared equals c squared. So I am looking for a squared. So what I want to do is I want to subtract b squared to both sides. Therefore, a squared equals c squared minus b squared. And we do want to find a, so the best way to do that is take the square root, right? And usually we put plus minus, but it's always going to be a plus because measurements are always positive. So then I get my final formula of a equals the square root of c squared minus b squared. So let's do it. equals the square root of 25 squared minus 7 squared. And if you switch the order on these and do 7 squared minus 24 squared, you're going to get a negative number under here, and the square root of the negative number will give you a non-answer. So always make sure its hypotenuse is first, the longest side of the triangle. Okay, and this gives you the square root of 576, which equals 24. So A equals 24. Okay, so now that we have this, sine R. So from doing this from R, this would be the opposite. This is the adjacent, and this would be the, again, the hypotenuse does not change, right? So sine R is opposite. So maybe I'm just going to get rid of this A right now because that might be screwing us up. The opposite is 24, and the adjacent, or sorry, hypotenuse is 25. You see the 25 right here, over 25, right? Opposite over hypotenuse. Cos is adjacent over hypotenuse. Adjacent, if you look over there, is 7, and that's 7, and then my hypotenuse, again, 25. And tan is opposite over adjacent, so opposite 24, adjacent 7. Now from sine S, like when we want to do it from angle S now, we basically want to get rid of all of this stuff. Let me get my equals 24 there. And this was 24, but now I'm doing it from angle S. So this would become my opposite. This is my adjacent, and this is my hypotenuse. Okay, so S opposite is 7, hypotenuse 25. Okay, so you're just keeping these. S, cos S is adjacent, which is 24 over hypotenuse 25. And 7 tan is opposite over adjacent. Okay? We don't need to talk about that. This, let's just go down here because this is review. So let's just figuring out how to find a angle. Okay? We haven't done any calculations right now, but here we have a telephone pole. It's 12 meters high, supported by a wire, 14 meters long. So the wire is 14 meters long, fixed to the top of a pole. Okay, so we got a 12-meter pole, and there's this wire that's fixed to the ground, and it's 14 meters long. And here's the ground. It wants the angle between the wire and the ground. It's looking for this. So if we do our, that's our opposite. This is our hypotenuse. So adjacent has nothing to do with this question. So that's why we're going to use sine. So we go sine, we'd go, let's call this x. Sine x would equal opposite over hypotenuse, right? So sine x, let's fill in what we know is opposite is 12 meters and hypotenuse is 14 meters. Now when you're trying to find an angle, do you remember? Remember from last year? You have to use second sine, okay, on your calculator. So, oops, let's bring my calculator up here. I think I opened like 3 calculators. Close this one. Oops. Okay, so sine. So I'm looking for an angle, so I go second, little arrow, sine, and it opens that bracket. Then I put my 12 divided by 14 in. Okay, now I get that. Now that's not the right answer because I'm in radian modes. So here, you see right here, you have your mode button. You do not want to be in radians. And every time you have to reset your calculator, it goes to radians because radians is a more common measure when you get to the higher levels. And then you hit enter and it should be sitting on there. And then if you get out of here and hit enter one more time, it'll give you the degree answer. So I put second sine. So maybe I'll take a screenshot of this. Oh, it's too bad I had the other. Here, I'll do this. Oh, never mind. Paste it here somewhere so you can see what I had to do. Let's just cross this out so students don't think you have to take the fifth root of something to do every time. So this was in radians, which I didn't need. This is in degrees, right? So we have to make sure mode degree. Okay, so we go second sine, 12 divided by 14, enter, and we got 59 degrees equals x. Okay, hopefully this is bringing back some memories from last year. Now calculating sides, let's just go and do one. So here we have a triangle, right? The triangle, let's label it. Okay, so here's my angle. So that is my opposite. This is my adjacent, and this is my hypotenuse. Now it wants the lengths of AB and AC. So let's first do AB. Okay, so AB from here is my opposite, and I know my adjacent. Okay, so let's do tan for that one, right? Because tan theta equals opposite over adjacent. Tan 74 equals the opposite would be my, we could just put O, and my adjacent is 109. Okay, now the way we do it is we bring this up here and clear, and we would just go 109 times tan 74, enter. So that's 380 feet. So I'm going to take a screenshot. Whoa. Okay, so that's how you do it. So this is 380 feet. Okay, now we want to find the other side. So the other side, we want to be using this. Try not to use this number to do your next one, because if you screwed this one up, this will be wrong. So why don't we do adjacent over hypotenuse, which is cos. Cos theta equals adjacent over hypotenuse. Cos 74 degrees equals adjacent 109 feet over hypotenuse, which is, we can just call that like h. Okay, now this one, these two will trade. So h will equal 109 over cos 74 degrees. So let's try it. Clear this. 109 divided by cos 74 is 395 feet. Let me just take a screenshot of this so people can see how I put it in my calculator. So h equals 395 feet. Okay, a monstrous question here. Let's do this question. So we got a large tree is to be transported to a new location. The tree is held vertical by means of two guy wires of unequal length on opposite sides of the tree. One of the wires makes an angle of 48 degrees, and the other wire is 12 meters long and makes an angle of 56 degrees with the ground. Both wires are attached 3 meters down from the top of the tree. Okay, so say this is like the right angle here. And then we've got a wire that is going 3 meters down. Right, so 3 meters, and then we're right there. So then we're going like to about there, and this is 12 meters, and it makes an angle of 56 degrees. On the other side, it would probably be slightly longer, because it's making an angle less. This would be 48 degrees. This, I don't know. This would be like my y, and that's my x. I don't know that. So the first to calculate the height of the tree, right? Well, we can use this formula, because according to this formula, we have, I guess, this little triangle here, right? And this is my angle, 56, so that's my opposite. This would be my hypotenuse. So opposite and hypotenuse is sine. So we could just go sine 56 degrees equals, oh yeah, my hypotenuse is 12, right? So hypotenuse, or opposite, is like my O over, or in this case it's my x, right? Right, we look right here, that's my x. So that would equal x over 12. Right, this comes up here. You go 12 times sine 56, and you get 9.9 equals x. Now, that's not the height of the tree, though. There's 3 more meters. So then we have to add 3, which gives me 12.9 meters. Now, determine the length of the other wire. Now, this one I kind of need to have to use this measurement. Now, I want to caution you, though. The measurement was actually 9.9485. So I got to use that for the next measurements. You never want to use your rounded answer. So now we're dealing with this triangle here. I know this is 9.94 dot dot dot. I don't know this, and I know this is 48. So that would be opposite over hypotenuse. So sine 48 equals the opposite, 9.9485 dot 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 divided by y in this case, because that's my y. So these two trade, so you got 9.9485 divided by sine 48, and you'll get y to equal 13.4. So that is the length of the wire. So the other guy wire, I cannot spell today, well, usually most days I can't. The guy wire is 13.4 meters long. Determine to the nearest tenth of a meter the horizontal distance of the ground level. So what we now have to be doing is finding A and finding B, and we're going to add those together. So this length here plus this length here would give me my entire length. Okay, so if we look at the one triangle, what do we know on this side? This is 56. This is 12. So this is my hypotenuse. This would be my adjacent. So I could just use tan. So tan 56 equals the, oops, why am I using tan? I don't need tan for this side because I can use, sorry, I could use tan, but then I'd have to use my new measurement. Why don't we use cos? So if we go cos 56 equals adjacent, which we don't know, over hypotenuse, which is 12. Okay, so the 12's coming up. So I would just go 12 times cos 56, 6.7103. So A equals 6.7103. Okay, now let's find B. B goes like this. Now B, I'm going to have to use my calculated 13.4, right? Or I could use the X, doesn't matter. But, well, why don't I use my X, because I remember what that was unrounded. So this is 9.9485 dot dot dot. This here, this angle, so we're just looking at this triangle here. This is 48 degrees, and I need to find my B. So now I'm doing opposite over adjacent. And again, if you would have used your opposite here, you could have done it as well. But I like using a value that was given to me in case I screwed that one up. But if I did, then this one will be wrong, so I guess I got to trust myself. So now it's just going to be tan 48 equals 9.9485 dot 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 over B. These two will switch, and you will get B to equal 8.958 dot dot dot. Now we want to add these two together. A plus B equals 15.7 meters if you round to the nearest meter. Okay. Now here's an extension. A guy wire in C breaks the new wire of the same length is attached 2 meters down the top of the tree. Calculate to the nearest degree the angle it would make with the ground. Okay, so this is kind of a weird question, meaning I'm going to keep this 13.4 meters for this, but we're going to attach it 2 meters lower and then reattach it to the ground. So what is that going to look like? Well, if we go like this I do not know. This is 13.4 meters. And this this was 12.9 from here to here. Okay. So instead of 3 meters, we're going to take the 9.9, or the 9.9, just add 1 meter. Or this is 12.9 from here to here. We can just subtract 2 meters from 12.9 and use that. So that's what I did for here. 12.9 was up here, and I'm going to minus 2 to get, so I got 12.9 minus 2 equals 10.9. Now I have my opposite and my hypotenuse. I'm looking for an angle, so I'm going to go second sine, which is sine -1, and it'll go opposite is 10.9, adjacent 13.4, that equals x, equals 54 degrees. Okay, so we're doing questions 1 to 7.